Hello everyone, thanks for joining me for this lecture. We will be applying our nutritional epidemiological sheet to evaluate a research paper by using what we learned in the prior lectures to help solidify those concepts. The article we will be reviewing is Meat Consumption and Risk of Colorectal Cancer. First, as always, my disclosures. I am an investigator in a study that utilizes continuous glucose monitors that are provided by Abbott. These are some of the key points you should have in mind when doing a first pass through nutritional epidemiological research. First, pay close attention to point 3, the time frame between food frequency questionnaire and the end of the study. Point 4, the number of analyses done. And 5, calculating the attributable risk, also known as the absolute risk, depending on if you're talking about exposures or risk reduction, and number needed to treat. Points 4 and 5 deal with multiplicity and effect size, respectively. We'll circle back around to this checklist after this example. This is the study we'll be talking about today. This study had just under 150,000 adults aged 50 to 74 years old. They completed a food frequency questionnaire in 1982 and again 10 years later in 1992. They were then followed for the next 9 to 10 years up through 2001 for outcomes of colon cancer. This paper highlights the multiplicity problem, which we'll discuss first, then small effect sizes. This slide is a general overview of the author's methodology and analysis. The authors used 3 sets of data: meat consumption in 1992 and total colorectal cases, the consumption in 92 and colorectal cancer subtypes, and sustained low or sustained high meat consumption between 82 and 92 in colorectal cancer subtypes. Of note, a major limitation of the study is that the 82 food frequency questionnaire only assessed the average number of days per week for 11 meat items. This means that eating 5 hamburgers in one day versus 1 hamburger in one day was counted as the same, meaning that meat was consumed in 1 out of the 7 days for both of those subjects. This is very crude and rudimentary data collection and a major limiting factor for that third set of data above. The study's food frequency questionnaire was validated against a 24-hour food recall and repeat food frequency questionnaire. As we saw in the food frequency questionnaire lecture, these coefficients are not good. The recall coefficient was 0.55 among men and 0.78 among women. The coefficient is slightly better for the repeat food frequency questionnaire, approximately 0.8 for men and women. To the right, you can see some of the data that has coefficients of 0.8 and 0.4. Finally, the authors investigated 3 models of data. We will focus on model 3 as that has the most covariance. In total, they controlled for total energy, education, BMI, cigarette smoking, physical activity, multivitamin use, aspirin use, intake of wine, beer, and liquor, hormone therapy use, fruits, vegetables, high fiber grain foods. Notably absent are high fat, high sugar processed foods, and likely some other environmental exposures that would predispose to colorectal cancer. Let's start with that third set of data from which the authors draw their conclusion. This is the meat consumption from both food frequency questionnaires in 1982 and 92 with colon cancer subtypes. The authors separated the data into 3 categories: low intake in 82 and 92, high intake in 82 and 92, and all other categories. From their conclusions, the authors reported that prolonged high consumption of red meat was associated with high risk of rectal cancer, particularly in the rectosigmoid junction. Table 4 shows this data as an increase in the rectosigmoid and rectal cancers from 65 to 89 cases for a relative risk of 1.43 in the red meat group, and an increase in distal cancers from 56 to 79 for a relative risk of 1.5 in the processed meat group. The authors did not give a p-value for these trends, as we see they will do for Table 3. However, these confidence intervals were quite large, and this one touched 1. Additionally, it is impossible to calculate the absolute risk reduction or attributable risk, as we do not know the denominators for these data. In other words, while we know that 65 people in the low intake group had rectosigmoid and rectal cancer, We do not know out of how many subjects this was. Thankfully, we have all of this data in Table 3 on the next slide. Table 3 shows the 1992 data alone in subtypes of colon cancer. With this data, we can apply what we learned regarding multiple comparisons. There are 12 associations on this table, and each have a p-value for significance of 0.05. As we discussed, doing multiple comparisons and keeping your p-value at 0.05 is like a child rolling the dice in Monopoly until they land on Boardwalk. While the authors set their alpha or type 1 error rate at 0.05, the family-wise error rate for this table with 12 outcomes is actually 0.45, meaning there is a 45% chance of a type 1 error rate in this table. To correct for this, we apply the Bonferroni equation by taking the stated goal alpha value of 0.05 and dividing it by the number of comparisons we are conducting, which is 12. This gives us a new p-value threshold for significance of 0.0042, making none of these significant. Finally, we can look at the effect size and count the number needed to treat. This table is based off the 1992 data that we saw on the previous slide. Effect sizes can sometimes be seen best with absolute risk or attributable risk and the number needed to treat. The paper reported a relative risk of 1.71 and did not give absolute risks, which can be misleading, as we'll show on this slide. First, for perspective, let's look at the top row of the table. The lowest quintile ate at most less than 6 ounces of red meat per week, which is approximately 1 hamburger. The highest quintile ate greater than 27 ounces of red meat per week, which is about 2 large ribeyes. In the second row of the graph, we see that there were 57 cases of rectosigmoid and rectal cancer in the lowest quintile. From table 1 of the study, I placed the denominator in the third row, which is 11,615. Therefore, dividing these, we can see that the absolute risk of rectosigmoid and rectal cancers was 0.49% over 9 years for the lowest quintile. For the highest quintile, there were 96 total cases of cancer. This was out of 11,380 participants for an absolute risk of 0.84% over 9 years. Therefore, the attributable risk is 0.84% minus 0.49%, which is 0.35%. Compare this with what was reported, which was a relative risk of 1.71, or a 71% increase in colorectal cancers, which sounds much more impressive and publishable. To further look at effect size, let's look at the number needed to treat. The number needed to treat is simply the attributable risk or the absolute risk reciprocal, which is 0.35, which is equal to 286. In other words, 286 subjects would need to eat who ate greater than 27 ounces of red meat per week would need to decrease their red meat intake to less than 6 ounces of red meat per week over the course of 9 years to prevent 1 case of rectosigmoid and rectal cancer. This number, when taken with other issues of this paper that we've discussed, is not a large effect size and certainly not evidence of causality. Worse, these effect sizes worsened when meat intake was adjusted for energy, and they did not control for many other problematic sources of nutrients, such as high carbohydrate, high fat foods or sweets. If we began to tell patients to eat less red meat, they might replace that meat with obesogenic food, which is causative of many diseases. I included some other selected numbers needed to treat so you can get an idea of what we do and do not recommend in medicine. Again, 286 patients would need to decrease red meat intake from greater than 27 ounces of red meat per week to less than 6 ounces of red meat per week to possibly avoid 1 case of rectosigmoid and rectal cancer over the course of 9 years. 333 patients would need to take a baby aspirin to prevent one non-fatal heart attack over 7 years for primary prevention, which we do not recommend. 217 patients at low risk of cardiovascular disease would need to take a statin to prevent a heart attack for primary prevention, which we also do not recommend. Finally, to look at a really good number needed to treat, the life-saving measures of lung protective ventilation strategies with conservative tidal volumes has a number needed to treat of 12 to avoid one death in an ICU stay in ARDS. Let's look at the epidemiological review sheet. This paper was not registered as registration started in 2000. Nutrients were collected by food frequency questionnaires, which are imprecise. These data were also not energy adjusted, and correlations worsened when they were. The final follow-up period between the last FFQ and study completion was 9 years, which, as shown by our first point on the typical recipe of nutrition research lecture, can mean variations of greater than 30% in all categories of nutrients and exposures. Overall, too many analyses were conducted without correction, and this study suffers from multiplicity, and applying the Bonferroni changes the conclusion of the study. The attributable risk was approximately 0.4%. There may be a causal link between red meat and colon cancer. However, I would err on the side of not calling that risk based off of this study substantial or impressive, as this news article suggests when the study was published. An epidemiological study with a relative risk of 1.7 does not meet statistical significance after correction for multiplicity. Other studies showing null results for rectosigmoid and rectal cancer and consideration of the inherent issues with food frequency questionnaires means you cannot determine causality from this paper. Keep this in mind when your patients ask you about the latest headlines regarding that eggs are good for you or bad for you, or whole grains are good for you or bad for you. These headlines most likely came from epidemiological papers, which are only hypothesis generating. Key points to remember from this talk is that epidemiological studies are hypothesis generating and you cannot infer causality, especially from these types of low absolute risk data. Additionally, for this study in particular, we have to be concerned about multiplicity when we compare the numerous exposures and outcomes and the small effect size as demonstrated by the number needed to treat.